Let me check the attendees here, see how we're doing on numbers. Yep, we're going up. Yeah, we're at that 5-minute mark, so people are going to start piling in now.
All right.
Yeah, get started in just a minute or two.
So 45 minutes before Q&A, would that be okay?
Yes, sir.
All right, cool. Keep an eye on it.
Yep, and then we're here too, so we'll give you a shout when you're just hitting up on your Q&A time, all right?
Mm-hmm.
All right, let me get that.
Sounds good.
All right, got the clock going. So I mean, yeah, on your mark, Alex, whenever you're set, feel free to get started.
All right, thank you, Mike. Hello, everyone. Welcome to my session on how to get to the sub-second page load time in real world with Sitecore JSS. Before we get started, I'd like to mention that there is a brilliant donation opportunity organized. So please, if you do have a few bucks to spare, please do so. Based on my rough calculations, we can get to $5,000 by spending less than a cup of coffee in San Francisco, where I'm based. So hopefully you can support World Health Organization, and they're doing amazing things, and they're at the forefront of this battle. So please, if you can, donate and help out. In terms of intro, for just a little bit my background, so you know where I'm coming from. I'm ex-Sitecorean after 13 years. Left about 2 years ago to start Altola, which is a boutique agency with a couple more usual suspects, my business partners. So we are now also running another company, which is a more product platform company called Uniform. So back in the day, I come from full stack background, so I spent enough time on the server and started my journey with .NET and C# and I transitioned to JavaScript a few years ago. And primarily, my journey started with a Path Analyzer project where T-Max in my Psycho days led that project, and Psycho JSS, all that original project and effort around that. And so JSS topic is near and dear to my heart, and I'm very excited to share accumulated experience, not just my personal, but our team that spent last 2 years in this area quite heavily. So in terms of format, and I'm hoping this agenda can serve the purpose of some thought framework that you can use for similar performance projects that you may be running. So first we'll talk about some theory, kind of warm up, talk about performance as a feature, the why, the what, the how, the who, and go into then more into practical area where we can get a site load fast locally first. Then we're gonna making sure it loads faster from multiple geolocations. Then we'll talk about how to keep this great performance that we're planning on achieving when you have you experiencing heavy load. It's a separate challenge. And finally, how to ensure you stay fast after you achieve all those numbers with more features being added. That's another angle. So hopefully I'll give you end-to-end kind of framework and a lot of resources I'll be sharing along the way. So first things first, why performance matters. Simple as that. It's all about losing visitors. So you're pouring millions and millions of dollars in your website, but if the site is slow, people not gonna engage and leave. And there is a well-known research at this point done by Akamai and Google that increase of load time from 1 to 3 seconds increases bounce probability to 32%. And knowing that this is pretty significant, right? If your site is all about revenue generation, this is huge. But also more recently, Google Mobile Chrome is pushing new features That's one of them is known as the badge of shame. So when the Chrome will actually suggest that the site usually loads slow, and that's something definitely none of the business folks want to see. So performance is not just a problem for developers, it's a problem for business. And we talk about usually in the classic web performance page load. But page load only indicates that the resources, all the resources the site needs are downloaded. This doesn't really mean much for modern JavaScript apps because there's a lot of other things happening after the page load event occurs. Because of JavaScript, client-side JavaScript, that's essentially, this is very much near and dear to Sitecore JSS because by default, all of the JSS apps are universal JavaScript. So as the application renders, all of that JavaScript used to render the page server side is rehydrated in the browser. So the cost of that, if you haven't seen this article by Eddie Osmani, is staggering, especially on mobile and especially not on the latest $2,000 iPhone. So if you, on average phone, you experience very slow performance, and it's very common on mainstream sites such as CNN.com. So keep that in mind, and this is where a lot of optimizations, a lot of creative approaches will be needed to offset this. Also, alternative to just speaking about page load, Google recommends finding the right metric for your particular app, a metric that actually makes sense to the end user. So whether it's first contentful paint indicating that something is happening when the site is being loaded, or first meaningful paint indicating that this information is actually being useful, or time to interactive, which means that the website or web application becomes scrollable, usable, and interactive. So you really need to find the right metric for your use case. Typically, we strive towards time to interactive. This is the most kind of aggressive metric to pursue, and it's the most meaningful based on our experience. But in your world, this may be different. So forget about page loads, find the right metric that is actually centered around your users and their experience. Then how do we measure it? There is plenty of tools. This is the best part of this area. There is Lighthouse. We know everything about Lighthouse. It actually comes as a hosted option. You can actually run it. There's some commercial products out there. You can run it yourself. You can run it as a part of your CI process in CLI. So many options besides just running in the browser. And web page test, this is another free tool that is critical to simulate location. So it can actually run Lighthouse, but also give you experience from a particular geolocation. So lots of tools. There is really no reason not to use them. And what I'd like to conclude this theoretical section with a couple of thoughts around how to actually win at performance. If you approach it as just your own objective or like a technical objective, that's not gonna resonate with all the other stakeholders. So if you really approach it as a business objective, you'll have much more success in actually securing right investment and buy-in from all the other folks. So treat it as a first-class feature, not an afterthought. We'll do that later in the project, two weeks before we go live. Being critical, super critical in achieving high performance means that certain decisions you'll have to be made in the beginning of the project, and certain compromises will have to be made with business. So that strategy needs to be figured out up front, and all that tooling process. This is the fun part. The hard part is to figure out all the business aspects and bring everyone on board. So if this is a big project, consider setting up, maybe it's an informal cross-functional performance task force from folks from business, design, front-end engineering, back-end DevOps that care about performance and make sure they can communicate the value of performance within their teams. I cannot stress enough how important that is. It's a joint responsibility. One example you can think of is marketing having access to tag management and adding new scripts that go completely by bypassing the release process. So that's a losing battle. If you spend months in performance optimization and you don't have marketing on board and they keep adding YouTube widgets on the page, all of that work would just go to waste. So make sure you're on the same page with business, and that will increase your chances at winning at performance. Now, in terms of more practical stuff, I have a couple of chapters. These are kind of phases and website optimization around specifically Sitecore JSS. A lot of topics apply not just to JSS, but some of them are specific to JSS. So first thing first, you want to make sure the site actually renders locally. You get high lighthouse score, and it renders fine on mobile. You don't have to do anything crazy. There's plenty of local tools for that. So we need a use case to consider, and one of the use case, because all of our customers are under NDA, I cannot really pull up anything from real world. So we have to imagine a new SUGCON site being built by a fictitious integration firm called Big Head Development, and this is a fairly problematic implementation we have got ourselves access to, and we need to optimize. So I want to show you the actual site before we go into all of the problematic areas. So the site is actually public. You can visit it yourself. All the links I'll provide a bit later. So this is built in Sitecore JSS with React, all the latest and greatest, and it's a fairly simple event site with some speakers and prices. And this site is already optimized, so you're not going to get terrible performance around it. It should render quite fast, but it's open source. So if you roll back to the initial commit in that repo that I'll share later, you'll get all of that terrible code that we're gonna go through. So if you want to experience bad performance and anti-pattern, you can. So the site is pretty straightforward. There's a lot of dummy content still, but you can see lots of components from third-party, YouTube, Google Maps. So it gives us a lot to play with. So as we're looking to the site, original score was 15, which is not the lowest that I've seen, but it's pretty bad. Time to interactive, 15 seconds. There's just no way to do this, and this was captured in mobile profile. So mobile users would definitely not going to be pleased by this. And there's plenty of optimization opportunities right there on the surface that Lighthouse suggested. It's all about images. Images are usual suspects. And also about JavaScript. There is 2.4 seconds of thread work that JavaScript parses execution time. That's just too much. Besides that, some CSS issues, stuff like that. So we need to focus on something. And just to demonstrate how bad things were, this is a waterfall from the past of 16-second load time. And we can even open it up so we can see how really bad it was. And specifically you can see images. One particular image took 15 seconds to load. So we can see and this was loading directly from media library without any optimizations. So this was Corey's profile picture for the speaker section. So really bad, lots of problems here. And images, the topic of images was covered pretty well by Vincent yesterday. So if you have missed that talk, I hope it was recorded so you can actually take a look. He went much deeper into this. So we'll touch on this topic. I just don't have enough time to actually go through that. in depth. But what I have prepped is an open source repo with different Git tags that you can then kind of go through them and follow this journey of optimization with me. So that's a QR code that will be traveling with us throughout the slide. So you can, if you miss it, you can open this up a bit later. So the site is open source fully, so you can take a look. So stage one, image optimization. There's a lot to talk about images, and this is a separate session and probably separate week-long workshop. But usually there's three key areas. First, you gotta have support for responsive images. There's two ways to do that. You can either do that with JSS Media Handler, has its own pros and cons. Because I'm a lazy developer and I have some budget in my project, I'm just gonna use a proper image capable CDN. There's many of options, Akamai, Cloudflare, Cloudinary, Pio, and Cloud Image. So many options that are really smart at images and do all sorts of stuff for you, resizing, cropping, optimization, stuff like that. So we're just gonna use that. In terms of image compression and adaptive compression, this is hard. You could do it yourself. There's some open source goodness from Sitecore community, but again, I'm a lazy developer. I'm gonna use a proper image CDN for that. And third option is making sure you're not loading images where you don't need to. So we're gonna implement lazy loading, see how that works. And some CDNs actually can do that for you by injecting JavaScript. We will do that with React because we already built, we can pull in a third-party JavaScript component for that. So image offloading. In this example, I wanted to play with Cloudinary for years. So this was my opportunity to see what's Cloudinary story, and it's pretty amazing when it comes to images. So everything from caching, so they will fetch from the Sitecore origin for you, cache it at the edge, responsive, adaptive compression. There's just too many features to list, but they also come with React SDK, which is outstanding. That's what prompted me to just plug that in, which is a Cloudinary React SDK. You install it, and then you use it as an image component. You pass the source from this is your origin URL, and then your account name. It will fetch the image for you, and it will handle responsive aspects as well. It was just a piece of cake. It got immediately, our lighthouse got bumped to 36, which is great, but also not good enough. Then we need to add lazy loading. Lazy loading, there is millions of ways of doing that in JavaScript and React. One of the components I like to use is React Lazy Load. Again, that's a great thing about building in JSS. You have access to amazing open source ecosystem. So this component effectively can wrap any React component or image in this case. You provide the offset height 200, and then it will load it when this image enters the viewport. So it's using intersection observer browser API for that. Easy, kind of silly not to do it. Immediately you get a score of 43. So that's awesome without much work. Moving on to another big area of optimization is JavaScript. There is likely, if you build in JavaScript, you didn't pay attention, you likely have too much JavaScript to run. So reduction of this JavaScript bloat, you can look at it from perspective of removing just unnecessary pieces you actually don't use. There's very likely you have a few packages stashed around that were not removed. Or find alternative packages. There is a lot more smaller packages available, and you can sometimes do pure JavaScript, and with translation, you're able to actually implement certain capabilities without using any third-party package, just by using modern JavaScript. So that site that was open source has an npm run analyze script that using Webpack bundle analyzer that you can run, and it will launch page like this that will allow you to see what's inside of your package. And this is great for analysis naturally. So you'll see things like lodash, moment. These are usual suspects. The font awesome library that turn out to be used for one single SVG icon. There's also stuff that discovered like Apollo client for GraphQL that was not even used. So there was a lot of opportunity to optimization. So first things first, lodash. Because this was built by Big Head development shop, that was probably not really up to speed with modern JavaScript. There was a few crimes committed here. Full import of lodash library, where I just need the get function. And if so, you could import just the get function instead of lodash whole library, which would be better. But there's even better option with optional chaining now available in latest Create React app. So you can just do that and ditch the whole lodash library completely. So that's great, easy. Then moment, again, another funny feature here with copyright year using moment.js, which is a quite heavy library because it comes with a lot of date locales for formatting. So definitely there is alternatives. There is a site, bundlephobia.com, that will help you navigate to find libraries that potentially 96% smaller than the library you use. In this case, just remove the library completely, replace it with pure JavaScript. Now, sometimes you cannot do that. Sometimes you just need a more lightweight alternative. This is just a silly example, to be honest. Just felt comical to use heavy library for copyright text in the footer. So the journey of getting there, pretty much we cut the bundle size from 742 to 476 kilobytes. That's a huge savings, and got to 51 lighthouse score immediately with that. That's great, but also not enough. There were some components there that we simply cannot cut out because we want to use Cloudinary SDK. It's quite heavy as it turns out, and Google Map React component for the Google Maps widget. We cannot just ditch that. We could probably do some pure JavaScript coded around that, but sometimes it's not practical. So what do you do in this case? Well, you can do what's known as bundle splitting approach. So effectively, you cut out those components that hopefully they're not critical components to be shown above default. So you can split them out in a separate bundle and lazy load them when they're actually necessary. And another awesome facility from open source React ecosystem, React Loadable Visibility, comes to the rescue. It will actually load up components that you tell it to load dynamically whenever they need it. And it's already wired up in that open source sample. You can take a look into the mechanics of it, and there is an array to specify components by name, which ones you want to split out of the main bundle, and the rest will be taken care of for you. That got us immediately to 252 kilobytes down from 476, which was just huge, huge improvement. In terms of result of that, immediately we jumped to 93, which is a good signal. Our time to interactive still pretty high, 3 seconds. We ideally want to go lower than that. So there are other potential optimizations. This is where you're entering the area of diminishing returns. So things like font loading, deferring to document load, that could help, could compromise your UX a little bit because your fonts will flash, but it may be, again, a compromise you may have to do with design team, or talk with them about fonts and figure out if you actually need 200 kilobytes of fonts on your website. I mean, you cannot beat physics at some point, so you need to agree on a compromise. There's also CSS purging tool you can plug in that will reduce amount of CSS to only what's needed to render, and some pre-connection hints that could help you to establish connection with the third-party origins a bit sooner. So this actually helped us get to 99. And this pre-connection of third-party, if you do have a lot of third-party, this could help quite a bit. So you can see this orange blocks where initial connection DNS takes place. You can move them a little bit early in the timeline. That could win you, maybe 50 up until 100 milliseconds maybe. So, but when you're in the territory of getting to 100 lighthouse scores, you have to you have to do everything in your power. Also, some lessons not from this project, this fictitious SUGCON site project, but from the other production projects. CSS, it's like shrimp cocktail. When you're having too much, it's not pretty. It's not a pretty site. So make sure you don't pull in the whole bootstrap or whatever framework you use. That could get into area of getting to 100. For sure. In our case, we had a journey of CSS and JavaScript where front-enders really wanted to use style components, but the CSS we had access to was just too much, and we had no control over CSS. So that created too much JavaScript, because that's what you have with CSS and JavaScript is JavaScript instead of your CSS. So this will definitely impact your time to interactive, and we had to switch to a zero runtime library called Linearia. It provides similar API to style components with some compromises, and that helped reduce the bundle size from 1.2 megabytes to 850 kilobytes. So definitely think about it. If your front enders are pushing for CSS and JavaScript, making sure they are the ones that are building CSS, and CSS is not coming externally. So if it's built with reusable component mindset, it shouldn't be that bad. But this was not in this case, and we had to make certain decisions. Fonts, again, font sizes, if it's a custom font, it can be quite huge. In our case, almost 300 kilobytes of font. So we cannot preload it. Some recommendations out there say preload the font. This was what we had with preloading. This is what we had with without preloading, with actual loading after document was loaded. That was a compromise we had to make, because otherwise there was no way to reach a low time to interactive. Again, your mileage may vary significantly depending on how many fonts, and fonts is another week-long workshop around fonts. If you're interested, hit me up. I have a couple of cool links to share on the whole font business. Also, trackers, another enemy of performance, third-party trackers. This is just a snapshot with same code with third-party script and trackers added through Tag Manager that shall not be named and without. So the difference is huge. I mean, it's pretty much double the time to interactive, more than that. So it's definitely a conversation you need to have with marketing. Do they need a 0.5 meg Facebook tracker script, really? And can they compromise on performance? So if you show them before and after, I think that's a conversation worth having. There's certain things you just cannot have at all. You cannot have 2 megs of third-party trackers and great performance, but you'll have to meet somewhere in the middle. So getting to 100 is hard on mobile, especially. Other things we had to do is disabling animation for above default components. That helped reducing time to interactive. So all the CSS animations, though they're fast, they will affect your performance above default. You'll have to fight for every 100 milliseconds. That's reality. And at some point, if you do have a lot of components, you may want to consider lightweight JavaScript UI library like Svelte or Preact. It's much easier to achieve numbers. Again, after everything is optimized, you should be pretty good state with React. I cannot speak in Vue, but Preactions felt that they built a bit more minimalistic, so you could get even further with those libraries. And another thing I've learned that you can actually base60 for your fave icon. There's a Stack Overflow post on that. That thing will help you reduce yet another request the browser will have to make, which is a pretty cool optimization, micro optimization. Now, it's all about client side. What about server side? Well, I just cannot go into too much depth here. Specifically for JSS, there are two main areas. I would say first is making sure you're not making more than one call, ideally for data. So layout service call should be all you need. You can bake nav data into it or bake that inside of the view bag, so you don't go extra for a separate data set for, let's say, your navigation or footer data. So everything your page needs should be in one response as much as possible. There are definitely deviations from that, but keep it minimal. Dictionary service, making sure you actually need it. If all of your components and their localizations are on data sources, it's unlikely you need dictionary service. It's render blocking. So unless you really need it, there are ways to optimize it, but making sure you're not using it wastefully. And ensure that you can generate response as fast as possible. So all those JSON renderings, like everything's cacheable. Make sure you cache them and make sure you don't return 400 kilobytes of data in your layout service response. You don't overfetch data. So, and that should ensure your server side should be in okay shape. But then there are other things to consider, like getting your site loaded locally is great, but you want to make sure you load it fast from where your users are. And this is just an example with Sitecore CD based origin deployed in Azure West US 9.3 XP extra large. I don't know how much it's going to cost me. We'll find out. And page visit from Chicago on fast cable network. And you can see time to first byte is already half a second. And a full just HTML load is 880 millisecond. You cannot get to sub-second page load if your time to first byte is that slow. So it's both server time generation and latency would definitely kill your performance. Before JavaScript and CSS can even load, you want to make sure you serve document as fast as possible. This is another example from same origin from Mumbai on cable network. Time to first byte, pure time to first byte, almost 1 second. So that's definitely not gonna fly for our goals of sub-second page load. And you can do a lot of things here, including page caching. It's tedious, but it's possible with custom cache keys. It will be hard. You'll have to think about how to maintain tracking, personalization. You still need an origin server in this case for CDN to fetch from, or that's something we doing more and more with our engagements is looking into build time page generation. So that's one of the key aspects of Jamstack, where you can generate the page at build time, deploy it to any CDN, and also can maintain personalization and tracking. Specifically, you could do Jamstack just to be absolutely clear without uniform. We built uniform to support this for sure, and ensure you can maintain personalization and tracking, and we facilitate the connection with Sitecore and support multiple targets. But the approach itself is pretty pretty conventional. It's like going back to early days. Pre-Sitecore of static publishing. So that approach of moving page delivery to build time, that's what you can do with virtually any cloud provider. In this case, you can push page at build time either through git commit or through publishing, push it to Azure Blob Storage with Azure CDN in front of it, and that will serve your pages and media as well as static resources. And for all the dynamic stuff, or tracking, data collection, you can still push into Sitecore and ultimately to XDB, but that's detached from the page delivery lifecycle. So in this case, you have a much faster way to get the page served up. How much faster? Well, about 10x faster. This is example, again, same code, same app, and the metrics are fairly similar between different CDNs. We're talking about under 50 millisecond time to first byte. And comparing with requests from Mumbai, which was even more challenging, it's 30x faster. So 35 millisecond versus what 1 second we had before. It's pretty significant, and that will also ensure it can scale better. This is after all the optimizations, the site deployed to Netlify or Azure CDN. The best number I was able to achieve was 1.852 load time, and it's that's the video proof of that. So the same site served from CDN, much faster. This blue line indicating load event indicates is between 1.8 1.9. So all the document loading took place, JavaScript loading, execution, even Google Tag Manager kicked in, the main image loaded, and then the rest was handled by service worker from a separate thread. So that something was at zero cost to user experience. So pretty fast. That's also came with a higher lighthouse score. So we got 100 and got to 0.9 seconds time to interactive, which on mobile, that's pretty huge. This is very hard to achieve. And all thanks to Next.js as a static site generator and plugged into Sitecore through our uniform plugin. So when you achieve these numbers, you want to make sure that you keep those numbers at scale. So I ran some tests just to see how traditional Azure PaaS SSR proxy plus content delivery decouple setup will scale on one instance where it would require auto scaling and adding multiple instances. And I found that it was pretty comfy at 75 virtual users on my tests, where average response time was okay, 0 errors. And it got worse, almost doubled with 100 virtual users, and at 250 it was just system was not really responding. So at that point you will have to make sure you scale out. So I want to compare this with the Jamstack architecture, and same 75 virtual users loaded without any break in the sweat. So I dialed it up to 250, 250 max users, 0 errors, throughput, 10x throughput with the Sitecore CD based delivery, and pretty consistent average response time. And you can see response time on this chart, which is kind of funny. Response times decreases, so the lower the better. It's faster response time, this brighter, I guess, purple line, and then the load of 250 users, it stays flat. So you can see it gets faster because everything probably higher, faster caches kick in with CDN. And in terms of maximum sustained load, who knows? I ran out of licenses on BlazeMeter to test, but at that point you test CDN. You know, like what's the point of testing CDN? I guess you can, but that's the whole idea of this architecture, is that you don't have to worry as much. And also, final step of after you achieve all of these numbers and you have proper architecture in place to support it, how do you keep it, right? As you keep adding more features, you can definitely need to identify performance budget and making sure it's validated. There is a script in npm run perf budget baked into that sample app that will validate if the app is actually adhering to the perf budget constraints, which is separate JSON file. You can configure Lighthouse checks in CI process, right? You can even run Lighthouse before you publish new content. So if something gets out to production outside of the release process, you can catch it through like a custom workflow action. So many cool things you can do with this. Tools are there. On top of that, you can use, there's plenty of cool services that, commercial services that run Lighthouse for you on schedule. So you can just ensure you keep your performance numbers up. And there's some resources I'll share around performance budget and how to set it up and keep ensure you keep to those numbers. Some of the key takeaways I wanna, if there is something I want you to take away 5 points, is that you really wanna, in order to win in performance, treat it as a feature and a really important feature. Stuff that you need to think about from the very beginning and keep top of the mind during the project execution and after the software is launched. So the organizational awareness and making sure you have folks on the same page and they understand the compromises that marketing or DevOps or IT or front-enders or designers have to make. You really need to be kind of all in this together to win. This is, I like to follow this approach. To me, it's self-explanatory. You make sure you run locally first, fast first. Then you want to make sure you run fast from the locations where your users will actually be visiting your site. Then you want to make sure you keep the same performance under the load, and going forward, you have the right checks and balances in place. It's hard to get to sub-second load time. It's fairly easy to get to 3 sub-second. Will require you to rethink the approach potentially, and that's why we love Jamstack, because this is a key ingredient to getting there and getting there consistently at scale and fairly cost efficiently as well. I think I have about 4 minutes before Q&A. I wanted to show you the site itself before wrapping up with some optimizations and specifically lazy loading, how this whole thing works. So let me zoom in a little bit. So this is the site served by Linux app service box. You can see I have just initiated full reload of the site. I can even empty the cache. So I got my document delivered 550 milliseconds of time to first, 500 milliseconds just for time to first byte for the document, and I get some CSS, some JavaScript, but I didn't get everything. So if I scroll down, you can see more images are loaded as they entering the viewport. So I didn't load all of the images. Also, code is lazy loaded. So if I switch to JavaScript, reload, you can see that some modules were loaded, but not all the modules. And if I scroll down to let's see, a little bit later, you can see the pricing section, and Google Map and YouTube loaded a bit later. And that's what pulled with about 3 more megabytes of resources together with it. So you want to make sure you don't load the YouTube or any embed for that matter before users actually need to engage with them. At least lazy load them so they're not loaded when they're below the fold. And that really makes a lot of difference. This is the same site rendered from Netlify. Again, same code. We can look into key differences that the document load is much faster. So it's 40 milliseconds versus 500, what we had before. This is the same site on Azure Edge. This is using, I believe, Microsoft CDN behind the scenes. And the origin is in Azure Blob Storage. So the whole site was deployed to Azure Blob Storage, which is this is what we can do, facilitated with Uniform. So I have a container with all my web files, and this Azure Blob container, it costs literally dollars to run. It has a static site feature enabled, so I can load the site directly from Blob container, but I'm not going to get compression and global distribution. So for that, I have Azure CDN enabled. And getting there, once you can try it yourself, getting there with Next.js and with the Uniform plugin is super straightforward. You essentially run npm run export, and after that you run npm run Azure, which is a script that will deploy the site to Azure Blob Storage. It will connect to the Sitecore origin that I have in running to the Sitecore CD endpoint, fetch all the content it needs. We'll do all the static generation for the whole site and all the pages, and we'll deploy it to Azure in just under a minute. We're done. So we just updated the latest Azure Blob container with a whole site. So the repos that we're sharing, there's a pure JSS repo. It was just open sourced a few minutes ago, and the one with Next.js and Uniform. So you can compare them apples to apples and see if you can. And it's the same presentation code, really the same app, just packaged differently and enabled with Next and a static export. So this is how to reach me. I'm on Slack, I'm on Twitter, and I want to thank you for joining and listening in, spending your morning, afternoon, night, whatever that is with me. And special thanks to Adam Weber. He helped me a lot with the review and fixing a few things. And so he's not presenting, but he definitely contributes a lot for that. And this is resources with QR code to the page with a bunch of links to the cool blog posts on performance, the sites, NPM packages, everything I just went through, and the copy of the deck as well, so you can go through this and revisit it, because I realize there's a lot of content, and yeah, you probably want to revisit a few aspects. And if you're interested in quick performance assessment, any first 5 inquiries to get a free quick performance assessment will get in. So if you're interested, let me know. This is how to reach me. And if you're running a Sitecore meetup, your own user group, and you're looking for a site to run it cheaply from CDN, we can give you a free Uniform license for non-commercial community use. Happy to do so. And with this open source starter kit, you should be able to build your own Sitecore community site with ease. It took me 2 days to build it. I used some Tailwind CSS components, so it was fun. It's definitely a learning experience if you're just getting started, and a cool project to have and launch in production. So happy to help if you have any questions. I think I'm good. Any questions?
This is Jason.
Thank you very much.
Just so the people that are on the call know, we're having some technical difficulties with GoToMeeting. It's reporting full, even though we're not full. We're not full by like 850.
Wow.
But probably due to the fact that we've been running for 20 hours. So probably a memory leak somewhere. They should get on that. We've got some people that are actually working on with GoToMeeting support to try to fix that. But in the meantime, we do have a couple of questions here.
All right.
So the first one, what about using catch point to measure loading time, because Lighthouse loc WTP just measures once, while Catchpoint is giving an average based on several measures.
But definitely, I mean, the more tooling, the better. I haven't used Catchpoint personally. I'm using web page test because it's free, easy. But if there is a tool that will give you, more insight, I mean, the more the merrier. I think it's less about tooling. There's plenty of tooling, more about discipline and organizational buy-in. So things that you discover in these performance tests can actually be acted on and not, shoved into a backlog for phase 2. That's that's more important than tooling, to be honest. But yeah,
Because we always know where phase 2 ends up.
oh yeah, I think there is a place for phase 2 somewhere.
All right, the next question, do image sprites help, or is it better to stick to individual images with lazy load?
Yeah, I think image sprites is anti-pattern as of now. So individual images, lazy loaded, definitely it's a way to go these days. I haven't seen sprites in a while, actually.
Mm-hmm. And the last question is, what are your thoughts about calling a third party through GTM?
Calling third to offset some of the, I guess.
All right, well, I guess we're...
Hey guys, so we're back on and broadcasting again. We had a glitch in the GoToWebinar and everything kind of went down. So I'm hoping people can join back in.
It looks like they're starting to pile
Hey,
in.
one of our presenters for the next session is in. Hey, Rick.
Well done. So
I
it was
just so you know,
Not exactly what we intended to do, but
Yeah, it worked out, I guess.
Well, just so you know, I did tell everybody before doing questions with Shyba that we were having troubles with it.
Oh,
so
good.
hopefully when it ended, people knew that it'd be back, because I said we were working.
That's really good. And
The
it just
rumor in the,
automatically ended, right? All of a sudden.
throw a tweet out.
Say again?
Go ahead, Ben. Go ahead, Benjamin.
Just saying we should maybe throw a tweet out, tell people to rejoin.
Yeah. Tweet.
The rumor mill, Akshay, in the questions panel is that you don't want to be anyone's friend.
Oh, really? Oh,
Yeah.
boy. Yeah, I see it right now. I wish. I like having a lot of friends. That's my... Oh, look at that. Hey, Corey.
You had me at metadata.
I did. You stopped talking after that.
Actually, I think the problem was probably Shyba didn't want to answer the rest of the questions.
Yeah, he ended the thing. Say screw you.
Should we go ahead and start the project, or did we already start it?
Well, we already started the broadcast. We have 8 minutes before we can start the presentation, so we'll wait for people to join. And then, Mr. Shaw, I think you read some names last time, right? From people who...
Yeah, I read names right before Alex started, so we could do the last
can you
hour.
read us the rest?
Yeah, not a problem. Be happy to. Let me pull it up.
Nice, low, beautiful voice, please.
Yeah, I'll enunciate. I'll try to go real slow. All right.
Ace, what is that?
You're an ace.
I think you pronounced that wrong.
Thank you, Corey. I like the pillow sitting on the table. On the chair.
We're now over 4,700 euros, which is good. We're creeping up there. We got a donation from Caesar about a half hour ago. Another one from an anonymous. We got Dennis Chernoff, Tyler Gramke. We're creeping up there, guys.
So, Mike, are you going to shave your beard to push this thing over?
No. I just donated. That was my.
Come on, man.
Like, we gave it the office.
You gonna do the mustache at the same moment? We'll do it at the same time.
No, I've already done that.
Okay? No.
He's done it once. Him and Cam. All right, guys, if you're joining us again, the GoToWebinar just crashed, so everyone's trying to come back in. We have our next session coming up in about 7 minutes from Rick and Corey.
Actually, if you want to throw presenter, I can put the same slide up and just make sure our screens are all good.
Will do. Doing it now. Am I giving it to you, Rick, then?
Yes, please.
Yep. You got it.
Hey guys, this is Alex. Are there any other questions I can answer, or those were the two? We lost the questions.
We probably lost the question.
Okay.
Well, actually, the Frederick that asked that tag manager question said, so we're basically saying that calling a third party through tag manager is very bad practice for performance. Smiley face.
Just to be honest, I'm not sure what the question is. Is this the tag manager was mentioned in context of more than just one Google tracker. If you just need a Google Tag Manager with the Google Tracker, it's probably going to be heavier than just a pure GA tracker. But there's other stuff that usually have pulled in, such as Facebook pixels and stuff like that. Some tag managers allow you to kind of funnel data collection through an intermediary and reduce the amount of trackers you actually need. So if that's a capability, that will definitely help. On this particular site, I enabled pure GA tracker, I believe in GSS and through Tag Manager on the other version of the site. So if I misunderstood the question, let me know on Twitter. I'm happy to answer.
All right, thanks, Shyba.
No problem.
What I missed?
Nothing.
Oh, okay. Sorry.
We sold all your protein shakes and spring water on eBay, so you should be
Where's my cut?
request to ship some stuff.
I want to cut.
It's all going to the WHO.
Okay. No, that's fair enough. It's perfect.
Where is the doll?
Huh?
What are you talking about?
Where is the doll?
I don't have a dog.
Doll. It was supposed to be in the back.
I don't think that I've ever had doll. I've heard it's very good though.
It was there in the chair, on the chair.
Oh, Dennis. Dennis is sleeping right now. He stayed up all night for SUGCON. He couldn't make it.
Dennis talks too much.
Okay, so I think I'm going to turn off my webcam, but you should probably get started coming up a couple minutes before the start time anyways.